Everything in physics is either about how things move or why they move in the first place. At its core, physics has two major frameworks: mechanics and field theory. Mechanics studies how objects move when something pushes or pulls them. Field theory, on the other hand, studies how and where those pushes and pulls originate. Mechanics splits into three branches: classical mechanics, quantum mechanics, and statistical mechanics. Classical mechanics explains the motion of everyday objects, projectiles, pendulums, and planets. It tells why spinning tops stay upright, how the moon rises tides, and how elastic materials and fluids move under stress. As the oldest among the six branches, it sets the conceptual foundation for the rest of physics. Quantum mechanics zooms into microscopic world of atoms and molecules, where particles behave like waves. It explains how the electrons inside atoms move, why glow sticks glow, and why materials conduct electricity, magnetize, or become superconducting. It explains every chemical reaction that can happen and why some never do. Statistical mechanics studies systems made of enormous number of microscopic constituents. It links their collective motion to macroscopic properties like temperature, pressure, and viscosity, explaining everything from why water feels solid when you slap it to why you can run across oobleck but can't stand still on it. Field theory also splits into three branches: classical electromagnetism, general relativity, and quantum field theory. Classical electromagnetism unifies electricity, magnetism, and light through Maxwell's equations. It explains optical phenomena like refraction, scattering, diffraction, and polarization. It underlies all radio telecommunication technologies and paves the path to unifying space and time in relativity. General relativity treats space-time as a classical field carved by matter and energy, forming the best framework that describes gravitation. It predicts black holes, gravitational waves, and the expansion of the universe. It explains why planetary orbits precess and how galaxies form, and it's essential for the positioning systems like GPS. Quantum field theory describes forces and particles as excitations of underlying quantum fields. It explains electron-positron pair production, nuclear reactions, and the quantum corrections to the Maxwell theory. It unifies electromagnetic, weak, and strong nuclear interactions into a consistent mathematical framework. It is the backbone of the Standard Model and particle physics. From falling apples to wiggling electrons, this is how physics explains everything we see and much of what we don't. Follow me for more.